was up to him, he'd say, just Amazon CTO for 20 years. But allow me to read. Our keynote speaker of the day is Dr. Werner Vogels, who's the CTO and VP of Amazon.com. Dr. Werner is a Chief Technology Officer at Amazon.com, where he's responsible for driving the company's customer-centric technology vision. As one of the forces behind Amazon's approach to cloud computing, he is passionate about helping young businesses reach global scale and transforming enterprises into fast-moving digital organizations. Vogels joined Amazon in 2004 from Cornell University, where he was a distributed systems researcher. He has held technology leadership positions in companies that handle the transition of academic technology into industry. Vogels holds a PhD from Vrije University in Amsterdam. I hope I got it right. Vrije. And has authored many articles on distributed systems technologies for enterprise computing. His blog, On his blog, All Things Distributed, Werner shares insights and thought leadership content on a range of topics, such as cloud computing, machine learning, of course, artificial intelligence, as well as annual technology predictions. So ladies and gentlemen, please help me in welcoming with a round of applause, Dr. Werner Vogels.
Well, first of all, thank you all for coming. Yeah, and I really need to do something about that bio. You know, after 20 years, you kind of feel differently about your job. When I was young, and you would have told me that I would work for 20 years for the same company, I wouldn't have believed you. I would have laughed you out of the room. Yeah, but Amazon is a very special beast in terms of sort of continuously innovating, and every year has been different. So what I want to talk to you about today is something that I've actually been really passionate about from the early days of cloud computing. But to be honest, it took me about 12 years to convince my customers that I was important as well. And this has a little bit of a history. So, if this works, that would be nice. Oops, can I go back as well? Yeah. Okay, so if I go back to the days, let's say, before cloud computing, when you think about Amazon, and so we were running our own data centers. Yeah, we had these rules that you needed to be replicated over 3 different data centers, things like that. But of course, Amazon was growing really rapidly, but we were really good in sort of predicting what sort of next year's traffic would be, or at least sort of the boundaries within. And so we needed to make sure that we had capacity, and that we needed to buy hardware for that. Now, if I was, let's say, too optimistic about next year's traffic, I would buy too much hardware, and my CFO would be angry at me. If I wouldn't buy enough hardware, my CFO might be happy, but my customers would be unhappy because I wouldn't have enough capacity to serve them. So we were always living within these hardware constraints. Whatever we wanted to do, it was just bounded by the hardware that we had. And so you can imagine that, so on a daily basis, traffic flows up and down. But then you get to what's called Black Friday, the month leading up to Christmas, where traffic is actually 4 times as much as on a regular weekly basis. And you can't just the day before that just go to Cisco or whatever and just suddenly buy 10,000 servers and run them into your data center. So you have to plan all of this. But also, when you would have everything in order, the days leading up to Black Friday, you're looking forward because you think you have enough capacity, looking forward to the all the customers coming to your site, and then there will be one team that's only 2 days before that shows up at your doorstep and says, hey, we have a brilliant new idea. Yeah? If we do this, if we implement this in the coming days, I think we can add $20 million free cash flow. But I hadn't planned for that. But for some reason, we always made it work. Yeah, and it has to do with the fact that if this would work, that would be nice. Oh, now it's gone to so constraints, these constraints, we always made it work. Yeah, and constraints breed creativity. You have to live within it. And so, there's always massive engineering creativity that went into it to actually make it work. Now, when we moved to the cloud, that all changed. Okay, cloud removed those constraints. Suddenly you could have all the capacity that you wanted. You no longer needed to think about how much of this capacity you needed to buy up front. You could just immediately sort of get started. And if you would have brilliant new ideas, fine. You just allocate some extra capacity. It turned out that it then became very more important for most of our customers to actually, so let me just move over here. Yeah, so we moved those constraints, and these constraints, we breed creativity. Okay, we've done that. Now, when we launched AWS, we had our first sort of big user conference, I laid out sort of a whole set of rules how I think cloud development on cloud computing would go. And most of these things, customers really followed that advice. Things like at least to deploy, if you have a production system, you need to deploy to at least 2 availability zones or data centers, if you would call it like that. Okay, yeah, good. Well, yours doesn't work either. Now, there was one statement in those 12 guidelines that I gave. That was, you should architect with cost in mind. Yeah? That when you build your system, now suddenly cost was explicit. Yeah? You should use that when you architect that. Every customer almost ignored it. And why? Because now suddenly moving fast and being innovative was much more important. Building systems much faster than that your competition did, for example. Yeah? So customers, I won't say completely ignored it, but most of them were much more, they were so happy to be the shackles of the constraints of having to buy your own hardware, actually really sort of made them happy and just went on a complete spree of sort of really being innovative. However, a number of years later, suddenly the CFO started asking, really, should this actually really cost this much? I'm not saying that it's very expensive, but what they did do is that, we have 2 different search services in our company. One of them costs twice as much as the other one. And so people started to sort of question whether that was the right approach. Have we really taken cost into account? Because after all,
if I do this,
cost really is an important. Okay, sorry. So cost really is actually really important. So what I did a number of years ago is actually start building what's called a frugal architecture. What are sort of the guidelines if you think about sort of incorporating cost in your architecture? Because it is crucial. After all, we build technology for a business. Yeah? And as such, cost should be part of that because it's a crucial part of your business as well. So I hope today to talk a bit about sort of what kind of the lessons that we've learned at Amazon Retail, Amazon.com, that I hope everybody else actually can take into account as well. Now, they put them in 3 different buckets. The first one is actually one of the things that I think is most important in all of this. And it has to do with the fact that you have to consider cost upfront before you start architecting. Yeah? Non-functional requirements are things like security, compliance, accessibility. I think those 3 are actually non-negotiable. There's no trade-offs against it. You can't go, you know what, let's do a little bit less secure. Yeah? That's not what you're going to do. These things are something, but the other things like performance and availability, scale, are things that you can trade off in your architecture. Now, I think cost should be part of that as well, because it's one of the trade-offs. Yeah? What kind of performance do you want? At what cost? Yeah? How available does each component in your system need to be? At what cost? It's obviously that a system that needs to be 4 nines available, you may need to actually spend more money on that than a system that only needs to be 2 nines available. So how do you reason about that? Those are trade-offs that you need to make. You only make them if you make cost explicit, yeah? Upfront. Now, the cool thing is, and I think if I think about sort of what are the good things that we've done at AWS, as much as that I love all the technology that we've built, and we built some really amazing technology that nobody's built before at any scale. But I think the biggest impact is that we changed the economic model. CTO of Amazon, to be able to drive costs down, I needed to make contract for a very long period of time. You know, if I wanted to buy databases from this database company, the only way to drive costs down is to make a 5 or a 10-year contract. And I couldn't even imagine how much I would need 5 years from now. I had a really hard time figuring out what is the next year. So you massively overscale, and you write this big check up front to this database company, you give it to them, and then they don't care anymore, because they got paid. Yeah? So the one thing that we wanted to do when we started thinking about how to build AWS is that we also wanted to change the model, because Amazon has as the motto to be Earth's most customer-centric company. So how do you build the Earth's most customer-centric IT provider? Is by giving your customers control. Yeah? They need to decide how much money they want to spend with you based on what they've really used. And so at AWS, we really wanted to be what we call cost following. The pricing that we charge our customers follow exactly the costs that we have. Now, that didn't always go well. Let's put it like that. The first services, we had to learn about this. And a great example is Amazon S3, which is a storage service. And so when we started that, we thought, oh, there's 2 dimensions where we have cost over that we need to charge our customers. So we started off with a charging model. We had to charge for the amount of storage you used and how many bandwidth you used. Obvious. Now, one of our first customers was a small business that stored thumbnails that were used on eBay. Now, thumbnails, very small, but they literally had millions and millions of these thumbnails. Stored them on S3, not that much storage. Yeah? And over the bandwidth usage was also not that terribly much. The number of requests was ridiculously high. And we started to realize that request was another resource that costed us money. This is the only time when we changed our pricing model, because we learned from that actually there was 3 dimensions over which we should charge our customers. And the third one was really the number of requests. So what I'm going to show you by this is that at AWS we really make sure that the pricing model that we give to you is exactly the pricing model for us. Now, we have the advantage of economies of scale. We lowered our pricing 165 times by now. Why? Because if we get actually advantages from the economies of scale, we show that to our customers as well, and we lower their pricing. But in our architectures, we've also really incorporated that. DynamoDB is a key value store that we have, and there's 2 types of reads. Yeah, so you can imagine that in the event there's a replication underneath there. And so if you want to have what's called an eventual consistent read, you only need to read from 1 node. As such, it costs 1 pricing unit. If you want to strongly consistent, magic, something happened. Again, here it looks good, but Okay, got it back. Yeah, strongly consistent means you have to read from 2 nodes to actually give a response back, and as such, it costs you twice as expensive. So here, we are like giving you a pricing model so that you can make decisions. If you can live with eventually consistent reads, then you can make your system cheaper. But if you really need to have this strong consistency, you basically need to pay double. But that's also the cost that we have. Yeah, very interesting presentation today. And so, for example, WeTransfer is a young business. I don't know if you've heard about them, or actually they're no longer a young business. They've been in business for quite a while. They have about 80 million customers, and this is if you have files that are too big to be sent by email. And then you can transfer them to each other. Many digital agencies are using them, and we're really talking about, really many gigabytes of files, things like that. So they did a re-architecture, really going through the whole architecture, because they're what's called a certified B Corp. That means that they have the strongest reporting requirements towards regulators about how much energy they're using. Now, energy and cost in AWS actually follow each other quite well. Yeah. If you think about sustainability, if you think about how we're pricing at AWS, it's the amount of resources that you've used. So cost at AWS is a very good proxy for how sustainable you are. If your system doesn't cost that much, you probably use less resources. Now, I would really rather report on, for your architecture, how many milligrams CO2 you've used, but it's very hard to reach agreements with other cloud providers and things like that about how to really achieve that, so you can compare things with each other. Until then, cost is a really good proxy for sustainability. If you think about, if you in your architectures you can reduce your cost, you also probably become more sustainable. And I think it's really important. I don't know how it is in your organizations, but quite a few organizations, the board already asks you to report on your sustainability. Yeah? And of course, we all don't want to ruin the planet while we're building our digital system. So keeping this in your mind is not only about cost, it's about sustainability as well. So non-functional requirements, I think these 2 things should be there, and you can trade them off. So consider cost at every step of the way. Every time you do a re-architecture, think about sort of the choices that you make and the kind of cost that you will occur because of that. Now, the second thing is that we don't build technology in a vacuum. We build technology for our businesses. So you need to be closely aligned with how your business operates. And especially if I think about younger businesses, this is the advice that I have always given them, is that you have to align cost and revenue. And what I mean by that is that, think about if you start your business, you think about, this is how I'm going to make my money. This is how I'm going to get my revenues going to come in. Then your costs should actually grow over exactly the same dimension. If your revenue is coming over here, but your cost is impacted by something completely different, you do not have a healthy business. Because eventually your cost may actually catch up with you. Now, whether you have a pay-as-you-go model, or whether you have a subscription model, or any other type of financial model, these are decisions you make up front that impact your architecture. You have to think about how to control your costs over time, and that depends on how you've actually architected. And if you do it right, economies of scale should help you. Then your margins are actually improving when your business grows, which is great. But it's only when you've made cost explicit in your architecture. And actually, to be honest, this is an example of, I think, won't call it my mistake, but I invested in a young company about 10 years ago, something like that. In those days, we didn't have Wi-Fi and 5G everywhere. So these guys built these small devices that basically connected to a mobile network and would give you Wi-Fi. And you would buy a 10 gig package every time where you needed more data. Well, it worked really well. But customers also got a bit annoyed by every time having to renew a package on their device. and suggested to the company that they should have an unlimited plan. And they didn't mind if that unlimited plan was going to be really expensive. So the company thinks like, hey, customers are asking this, sounds like a good plan, let's make it really expensive. Yeah? So customers then buy the unlimited plan, really expensive plan, and what do they start to do? Watch Netflix 24/7 over the device. Pretty quickly, the cost of the company completely explodes, in comparison to even the highest price that they've charged the unlimited model. This company went out of business because of that. Yeah, because their costs were rising over a dimension that our architecture couldn't support. And the business couldn't support either. So keep in mind that cost is a very important part also of the livelihood of your business. And if you think about sort of flywheels that you have to build, sort of think about where your costs are coming from and what you can do with your cost. This is the original business architecture from Amazon.com. Jeff wrote it indeed on a napkin. So if you think about retail, what drives retail growth is the number of products in your catalog. Yeah? The more products in your catalog, the higher the likelihood is that your customers can find what they're looking for. So if you have a really large catalog, customers won't go to Google or Microsoft or whatever with their search. They'll start at your place because the likelihood that they can find what they're looking for is very high. That drives more customer satisfaction, it drives more traffic to the site, and then sellers are becoming way more interested to sell on your platform, and that means you get more products into your catalog. So this is a flywheel that sort of accelerates itself. Yeah, because more and more, and now by the way, about, I think last Q4, about 60% of the units shipped on Amazon were third-party products. And so I remember when in the early days when we were the only seller on our platform as Amazon, and we knew that if growing the catalog was that important, we needed to change business decisions, namely to allow other people to sell on our platform. Because that was the way to actually drive the growth of the catalog. Now, if this works out, economies of scale will help you, and then you use that money to actually lower your pricing, which then becomes another sort of part of the flywheel. So you have two flywheels that are continuously accelerate each other. But important there is that you need to know your cost, and you need to have cost as something in your architecture that you can actually manipulate. Now, these two things work in close relationship to each other. I've seen quite a few enterprises in bigger businesses where sort of business and technology groups are completely separate from each other. Yeah, and where, basically to the technology organization, the rest of the business is their customer. And so that's the interaction. But you need to be closer together. You need to be in the same room. Why? Because business decisions have impact on IT. We as IT professionals shouldn't be the one in charge of making business decisions. But we should be able to build architecture such that the business can make those decisions. And we'll get a bit more into detail a bit later what I really mean by that. So it's also that sometimes you don't know up front how fast you're going. And you make decisions that you have to pay off later. If we have a house mortgage or we have a loan, we all know that we need to pay off the loan. We all know that we need to pay off our debt. Technical debt is the same. You have to pay it off over time, because otherwise, nobody's going to come and repossess your architecture, but your costs are going to explode in such a way that is not maintainable. You have to pay off your debt over time. And this is a general statement. If one of the things that we all know is that the architecture that we built on day one is probably not the same architecture that we'll be running 2-3 years from now. So up front, you need to already realize that your system will need to evolve over time. And that's another decision you have to make up front. Make sure that your system is built in such a way, in my eyes, decompose into small building blocks, use cells, things like that, architectures like that, to actually help you grow over time. I gave the example of Amazon S3. When we launched S3, it basically was built out of 6 small microservices. Yeah? Now it's 250 microservices. And for example, we changed storage methodologies under the covers. And we added all sorts of new functionality to it. Automatic processing of, automatic moving of stale data into cold storage and things like that. Without customers ever noticing. Yeah, this system has been running for 15 years. We never took it down. We changed software underneath there. It was almost like starting with a single engine Cessna, yeah, and then moving over to a 777, and then now it's a whole fleet of C-80s. And we've been moving customer over from airplane to airplane without them ever noticing it while refueling in midair. Yeah? And that's what you do when you build evolvable systems. You realize that systems are not static. Yeah? You need to have control over how they evolve. And so if you think about sort of in all of that, if you have the architect, there's all these non-functional and functional requirements that become trade-offs to each other. But you need to be aware of them. Now, if I think about, again, I think accessibility, security, and compliance are non-negotiable. You can't go to if you're a financial services institution, go to your regulator and says, yeah, well, we're kind of compliant. Yeah, you either are compliant or you're not. Yeah, so it's not a negotiation there. There's quite a few other things that you can trade off against each other. And for example, one of my interesting customers in Brazil, the Brazil Central Bank went to a completely different payment methodology called PIX. Basically, every transaction needs to be completed within 10 seconds. Became extremely popular, and all banks needed to implement this. They were only able to actually implement this by keeping cost in mind, because the cost is now per transaction. How do I keep control over that each transaction is only costing me a certain part for my architecture, not only the whole overall thing. And if I grow, the cost is allowed to grow with each transaction, because that's how I'm making my money as well. So you have to really think about what are the priorities in that. Is availability your most important thing? Is performance important? Or maybe cost is really important. I met last week in Nigeria with a company called Seamless HR. I don't know if you know them, they work in many different companies, but they build these HR systems for blue-collar workers. That's not high-end subscription payment models. These are razor-thin margins, because you can't charge too much for that. And so because the margins are so razor-thin, their architecture is crucial, because it's the major cost of their system. So a subscription model versus a pay-as-you-go model determines there how your architecture is going to look like, if you can still have an affordable business. So you really need to figure out, what are my priorities in all of this? By the way, Nubank, it's interesting, every team has a cost champion. That means even your teams are maybe 10, 12 people, at least at AWS that's the case, there is someone on that team who is responsible that every time we go through re-architecture or think about the system, whose task it is to say, how much is this going to cost us? And are those the right decisions to make? Well, most important, and I think there's a few practical things, and this is probably the most practical thing that you can do, because it will impact immediately how you build your systems. You have to make explicit and show it how much this system is actually going to cost you. And the best story I know that to compare that to, this is my hometown of Amsterdam in the Netherlands. 1972, we went through what's called an oil crisis. There was the days when the hijackings of airplanes were happening and things like that. And we had carless Sundays. Nobody was allowed to drive their car on a Sunday anymore, just to save oil. What they also did was looking at the energy usage of different families in different houses. And it would be sometimes the case that the houses would be identical, the family makeup would be identical, yet some of them are using 50% more energy than the other ones. And that was actually shocking, because how is it possible that two families that are identical almost use so much more energy? And it turned out that the difference between those two families is that the ones that were using more energy had their meter in the basement, their energy meter. The ones that used less energy had their energy meter in the hallway. That meant that every time you came into the house, you were sort of exposed to how much energy you're using. So just making it visible what the resources are that you're using impacts behavior. Yeah, because here the meter was in the basement, people didn't even know how much energy they were using, and it just weren't saving it either. Now, these are the things that I think have impact on the way that we build our systems as well. You know, if you think about cost, there's so many different angles of cost in your system. And I'll give the examples of Amazon here. You know, we have literally dozens and dozens of UI features on any web page. Yeah? So you need to know what kind of costs are associated with that. This is the Amazon backend. Yeah, each of those dots is a microservice. By the way, yeah. If you hit a web page, it will go out to maybe a dozen of these microservices, get the data in, and so you need to know what the costs are per each of those features. Now you need to know what each request for that particular component on your web page costs, how much the overall actually accessing cost, and then what's the impact actually on your business. These are metrics that you need to follow. And definitely if you see these things, if you think about new features, you need to be able to measure what the impact is on new features. Yeah, so you need to have an A/B testing environment where you can bring in new features and then look at sort of what the impact is on your business, but also impact is on your cost. How much does it cost me to deliver this new feature to customers? And that makes you a sustainable business. Yeah, and really look for diminishing returns. You know, sometimes you don't know about how much things are going to cost you until you really have to scale up. Yeah, remember I earlier said that economies of scale should help you, but if you don't see that it's helping you, that's a massive alarm bell that should go off and actually make you reevaluate how you've built your systems. Now, it's important for you to, what I call, define your own meter, define your own energy meter, and make it explicit to everyone. You know, one of these things is that, you know, when you used to be a developer in earlier days, before cloud, you would probably have a server or a massive desktop sitting underneath your desk, and when you would go home at night, you would just leave it running. Yeah, but you had paid for it anyway, already. In the cloud, however, if you leave your development environment running at night, it will cost you. Yeah, so when you go home at night and you turn off the lights in your room, you should also turn off your development environment. Yeah, make the cost of your development environment obvious. Put a screen on the wall, yeah, that says this is the amount of money we're spending on development. And then if you turn off your development environment and you see sort of these costs dropping, that's motivating. Only change behavior if you can actually make things explicit. Now the other thing is, and it comes back to that, you need to decompose into smaller building blocks such that you can actually tune your architecture. You need to give your business tools and mechanisms to make these decisions. And let's look at those. So in AWS or in Amazon Retail, we basically have decomposed the complete Amazon application. Yeah? We've built them into what's called tiers. Yeah? Tier 1 are those components of Amazon.com that always need to work. Search, browse, shopping cart, checkout. And probably reviews as well, because if reviews don't work, people don't buy. Yeah, so these things are tier 1. That means they always need to work. Then you have tier 2, which are things that are kind of important to your customers when they make buying decisions. And it may have impact actually on your conversion rate and your impact. So those are things like recommendations, customers who bought X also bought Y, these things buy better together, all this kind of additional information that you would normally want. And then there's tier 3. And tier 3 has kind of those features that are nice to have. But if they're offline, I won't say nobody cares, but it doesn't have significant impact on your business. Bestseller lists, for example. If a bestseller list is offline for half an hour, I don't think we get any complaints about that. Yeah, so if you would sort of lose a data center and you would need to fail over to another data center, it doesn't necessarily need to be automated. Yeah, it could be it could be done by hand or something like that. That means that tier 1, 4 nines available. That means you need to replicate over 3 data centers, at least. Tier 2 needs to be 3 nines available. Means replicating over 2 data centers. Yeah, tier 3, 2 nines, fine. Yeah. This means that each of those tiers have different costs associated with them. These are business decisions, by the way. You decompose your system into the building blocks and have a conversation with the business how much they are willing to pay for reliability for that particular component. And so this is a conversation that we as technologists need to have with our business, but we need to have decomposed our system into these building blocks such that we can have this decision. The business needs to decide, how much latency. Or it's not only about reliability, but it's also about performance. Those are things you trade off. But you can only trade them off if you don't have to trade off the whole block, but you have individual smaller blocks in all of that. And there's many different, it's not only on or off. You might throttle things if they start costing too much, or maybe the quality of your imagery is something that you sort of turn down if the traffic rises, or maybe your connectivity is not that great. And there's all sorts of other mechanisms that you have and that you can give to the business to actually help them make decisions. We as engineers should not be making business decisions. We should give business the tools for them to make the decisions for you. This is a collaboration. And so, give controls to your business, but you need to implement the controls first. Otherwise you can't do that. Establish your tiers. I think decomposing into building blocks is not only important for evolving your system over time from an architectural point of view, it's also important from a conversation with the business. How reliable does it need to be? How fast does this need to be? What kind of constraints do we have around that? Now, we're not only building new systems. I mean, quite a few of the systems that we run for a much longer time than that we're actually building it. So it is also a continuous effort, and we have teams at Amazon that do nothing else but actually look at existing code and see, is this still the best way to go? Remember that these days everything is about Gen AI and things like that. But 5 years ago that was not the case. And 10 years ago we were even thinking about that. So things change over time, methodologies change over time. Programming languages, environments change over time. You may actually have an architecture that runs much better on ARM chips than on Intel. Or do you really need these GPUs? Okay, you do it on your CPU. These are decisions that you change over time as well. And especially if cost is important, these things are important as important decisions as well. Going on to the Amazon Graviton chips, which are ARM chips, easily reduces your cost immediately by 30 to 40%. But it doesn't come for free. You need to do some re-architecting work to make it sure it really fits that new chipset. But these are decisions that you have to make. And so you have to continuously look for, what are my digital waste? Where is this? And I remember one of the most, it's an example from quite a while ago, but we used to indeed have, I think we had 56 different search engines inside Amazon, because everyone had built their own search engine. Some of them were twice as expensive as the other ones. And trying to figure out why that was, turned out to be something really simple. The ones that costed twice as much money were running on 32-bit architectures. The ones that were more efficient were 64-bit, because you could address more memory more efficiently. But you have to investigate these things continuously. That's an example from the past. There's probably newer examples as well. And there's so many opportunities continuously. Is this indeed, I think, so many different instance types that we have these days. What's the right syntax type to have? Okay? And we give you tools as well to see whether you match your application that you're building in what instance type would that be most efficient. And really reduce your cost. Now, profiling, of course, is important. I'm afraid for some of you, I'm going to show you 2 lines of code in a minute. So don't accuse me of sort of making it too technical. But this was, for example, one of the applications we had and well profiling it. Then this one had been running for quite a while. It was quite expensive. We didn't realize well. Turns out 40% was actually the part that did network communication. It was completely unexpected. This had to do with that whenever a request would come in, you pass the request, if it would be and it may throw an exception if it didn't meet certain conditions. Yeah? Perfectly right code, absolutely. Turns out 90% of packages match the exception. And exception handling is extremely expensive. Just changing that from an exception handling to just an if-then-else statement sort of reduced the whole thing by 90%. Yeah, so before that, now suddenly you see a complete shift in communication. These are simple lines that we sometimes have introduced in the past that we have completely forgotten about, but that actually may be decisions that impact you. We talked about them earlier, and this is a very fun story that's similar to what I just told you. So whenever customers would upload something, files to be transferred, their customers would download it, and after that the file could be deleted. But there was always customers that would come back after they deleted the file, say, oh, do we still have it? We actually need to distribute it once more. We don't want to upload it again. So someone in the early days of WeTransfer had put a line in the code that says we'll keep it for 7 days. It was just hard coded. Yeah, and nobody was ever thinking about that before because that was actually introduced on day one. Now 5 years further, the person who wrote that line of code is no longer there. By actually, so what they did under the covers is change those 7 days to 2 days. No customer ever complained, yet it reduced that cost by 16%. And 16% in storage cost was their major cost. So going back to decisions that you've made in the past is actually kind of important. You know, and so you have to continue. This optimization is not something you do up front. Yeah? We all know about premature optimization. You make wrong decisions. You need to know how your system is running. And so optimization can only happen later on. And the last one of those lessons is something I think that is more and more important today, more than ever. Yeah? If we go to Grace Hopper, which was one of the first famous programmers, and she was a rear admiral later on, she had this statement that says the most dangerous phrase in the English language is we've always done it like this. Yeah? This is really important because it actually impacts the way that we build our systems. Yeah? We're a Java shop. Yeah, that means you always program in Java because this is what we're really good at. Or we're really good at Rails. Yeah, or this is how we always built a system similar to this. And we did it like this, let's do it exactly again. Yeah? But, you know, our world is changing so fast. Our technology world is rapidly evolving. You need to continuously re-evaluate whether the tools and the techniques that you're using are the right tools. And one of those is actually programming languages. If you're considering cost and sustainability, yeah, if you then run by the way, the cost to operate, the cost to build is actually dwarfed by the cost to operate. So the exact cost of your system is probably going to be how long you run it over time. And that means, you know, how efficient you can be in your programming language in your environment has a crucial impact on your cost. So there's some research done around the energy efficiency and there's also the cost of programming languages. Languages like Python and Ruby are 75 times more expensive than languages like C, C++, and Rust. Now Rust is something that we are sometimes rebuilding our complete systems on AWS. Why? First of all, the security parameters are much better for that language than any other language that there are. But at the same time, you drive your costs down by 75%. That's significant. By just thinking programming in different. The time to learn how to program in Rust, if you're already a Java programmer or something like that, isn't years, it's just weeks. If you're a good programmer, you pick up this stuff continuously. By the way, if you're a technologist, we're in for lifelong learning anyway. Yeah, you might as well prepare yourself for starting to learn new programming languages if it turns out that the impact on your systems is significant. And languages like Rust are a great example of you improve your security posture and you reduce your costs significantly. Yeah? Now, sometimes you actually don't necessarily, sometimes you make decisions that are maybe less efficient. When we started building Amazon Fresh, that was our grocery store, we had no idea how the user interface to the customer should look like. So we started off on Ruby on Rails, knowing that once we'd reached stable state and we knew how it was going to look like to customers, we would have to rebuild it in a much more efficient environment. Yeah? Because Ruby on Rails, as great it is to do experimentation and build systems really fast, are a really big fat system that takes up a lot of energy for many of the features that you probably not even are using. So these things are important. Continuously reevaluate them. And the same goes for the way that we sort of do these development methodologies. And I thought that doing things like waterfall model and things like that were things of the past. But if I look at 3 recent failures, this is the NHS in the US, in the UK. They wanted to build a completely new system, spent $10 billion more on the system, and never launched it. Yeah? ASX is the trading exchange in Australia. They went, we need to go to blockchain. Yeah? All future of transactions will be blockchain transactions. Yeah? $160 million cost, and never were able to deliver on it. Lidl is a retailer in the US, in the UK, and they build a system on top of SAP merchandise. But the way that SAP sort of has built a system is something that you need to follow their principles and methodology. Lidl says, no, we want to do this our way. Yeah? 500 million euros write-off, never launched. If you think about all these, what have all these things in common, is that they're kind of stuck in an old world. And once things start to fail and fun things don't start to move that fast, they're doubling down on it. Instead of taking a step back and say, this is not really going the way that we wanted, let's reconsider this. And so most of these is that they are thinking about a massive system that they need to build. Building massive systems takes a lot of time. And what happens is that, in general, your customers are changing their mind. I mean, we've all been in a situation where suddenly, you got this list of requirements from your customers, internally maybe, and then a few weeks later, they think, we changed our mind. We think this should be different. But if you have this massive approach to building the whole system in one, you can't change. You become inflexible, and you lock yourself into thinking that that's the way it should be. The important thing here, and I want to really hammer it down, build evolvable systems. Evolvable systems means start small. Small building blocks that you can start to incorporate. Have a success with one smaller building block. Then build the next block. Then need to build the black box. If you really are going to boil the ocean, you're not going to work. Yeah, we all know that doesn't work. And so don't do this in your own systems as well. Continuously challenge yourself to think about, is this not only the right programming language, but is this the right programming methodology or development methodology for the systems that I want to build? Yeah? If always done it this way, it's very dangerous. So always challenge yourself about sort of, this is the belief that we think we should be doing this. Take a step back. Is this the right programming language? Is this the right platform? Is this the right architecture? What kind of GPUs do we need for this AI stuff that I'm doing? Things like that. So these lessons that we put together is called Frugal Architecture Lessons. There's a website, frugalarchitect.com, where not only these lessons are kind of explained, but we also do podcasts and sort of articles with some of our customers that have gone through this sort of lessons learned over time and all have their own sort of look at how did we control cost. The last one is with, for example, the folks from HBO Max. They merged two of these streaming services together, and they knew they needed to scale massively. And so how, if you have these massive peaks, how do you build an architecture for that you can actually afford? Now, a really important part, and I think definitely, I mean, it's hard to talk these days about technology and not talk about AI. Yeah? But I want to give you one thing of advice around AI. Don't let the media determine what your architecture is going to be. If I talk to customers, or actually just in general, people that are in IT and development, everybody's overwhelmed. I mean, there are 5 to 10 new models every day or every week. Which one do you use? Yeah? And then Apple comes out suddenly 2 days ago with a new paper that says, yeah, those reasoning models, they don't really work. Yeah? So what do you, and of course the media goes immediately jumps on top of that because they love a negative story and competition, things like that. If things go well, you'll never see a headline in the media about it. Yeah? So what should we do as technologists? Yeah? We should experiment. We should trust ourselves in terms of making decisions. We should actually, and that's actually what we want to achieve with Bedrock and all the tools that we've built. Yeah? There's a great thing, you know, we suddenly are all talking about AI, but AI isn't that new. The term artificial intelligence was coined in 1956 in a workshop in Dartmouth by at least 2 famous researchers, Minsky and McCarthy. And so they really laid the groundwork for what we now know as AI. But McCarthy has this famous quote as well. He says, as soon as it works, we don't call it AI anymore. Yeah? We call it image recognition. We call it natural language processing. We call it video recognition. We call it forecasting. We call it all these different things. We just don't call it AI. And if you've been an Amazon retail customer, you've been using AI for the past 30 years. We just never called it like that. We call it recommendations or fraud protection. Or, for example, where we're putting a lot of effort in now is counterfeit good detection. Last year, we eliminated 15 million listings on Amazon.com of counterfeit goods. The tools you use underneath there are AI. They're not just generative AI. Yeah? Remember that there's all these technologies underneath there. There's been deep learning, went to reinforcement learning, supervised, unsupervised, all these kind of things. They're really good working technology. Generative AI, different story, newer technology, but we still have to figure out exactly, I mean, it has great promise, but what can it really do for us? If you want to have a self-driving car, I suggest you do not use generative AI, but maybe you use supervised learning AI or reinforcement learning. You don't want this generative AI thing suddenly to make up a road on the right and then drive into it, just because it didn't know what was there. Yeah, because we need to know what are the advantages and the disadvantages of these technologies. And all these technologies from the past, which were AI, have been applied over and over again and are still great tools. The fact that these tools are there, like image recognition, doesn't necessarily, it's much cheaper than running these large language models, so cost is important there as well. But we also have seen that these are being used to really have significant impact, these tools, on, for example, healthcare. Lund University using image recognition, so in Sweden, women over 50 can get a mammogram every 2 years as sort of early detection of breast cancer. Now, radiologists that need to look at these images, looks at thousands of these images a day. At the end of the day, his eyes aren't that good anymore. AI, image recognition, will find 30% more cancers than a single radiologist, or as much as two radiologists independently looking at these images. Quite a few babies, or actually quite a few, a number of babies are born with birth defects, brain defects. But we have no tests for them. We test their eyes, we test their ears, things like that. We don't test their brain function. And so this is young business that uses a small cap on the head of a baby, gets the EEG, the signals from the brain out of that, which are very different for a baby than that for a grown-up person. And actually can determine whether a baby has a brain defect or not. This should be a test that every baby should undergo when they're being born. Because in general, if they do have brain defect, it won't show up for half a year or a year, by which time it's too late to intervene. So Jacaranda Health in Kenya has actually built a system to actually support pregnant women. It turns out that still quite a few pregnant women are not making use of healthcare when they're pregnant. And so they want to build a very low interface system, have an AI system at the background that actually understands sort of the kind of all the different issues that pregnant women can go through. And so they built a very simple SMS-based system. Send us an SMS with sort of your concerns or things that are going on, and you get advice back. Having low-cost infrastructure, low barrier infrastructure is crucial there. Now, why are we actually having all this talk about sort of the new AI versus the old AI, which all seems to work? It has to do a little bit with this. This is how technology used to be adopted. Yeah, you started off in the lab, you get your early adopters, and you start to educate people about the technology that you've developed, and then you get the early majority. It's a classic. Yeah? Sometimes in the earlier days, like with spreadsheets, for example, took 20 years, this trajectory. Yeah? Spreadsheets were developed in the 60s, became commercial in the 80s, and now there's basically just one player left. Now, by the way, there were whole floors at JP Morgan of accountants with calculators. They were a human spreadsheet. When spreadsheets got introduced, they didn't fire the accountants. They got better jobs. They got jobs that actually use their brains instead of only the calculator. Now, what happened with generative AI is that we completely skipped this. Now, things went from the lab in front of consumers, not even as technologists, in front of consumers without educating them. So nobody knew exactly what could this technology really do, and more importantly, what is it that it can't do? Or where are the risks? And so for us, I think it's still important, the most important thing that we can do as AWS is help you make these decisions about, for this particular problem that I have, what kind of models should I be using? Because these kind of things is stuff that the education that normally goes ahead of introducing new technology was never done. You also see many knee-jerk reactions. Governments will say, we need an AI Act, because we need to control this, mostly because it's uncertainty. And other companies are going for FOMO, fear of missing out. We need to do generative AI, without really knowing what are the problem spaces in my business where this is really the most effective for. So the offering is overwhelming. And I see a lot of anxiety with customers about, so am I doing the right thing? Where should I be applying? Will I be still be competitive if I'm not doing this in 2 years from now? So for us at AWS, our goal is to help you make these decisions, to experiment, to give you an environment where at low cost, you can actually figure out, for this particular problem that I want to solve, do I really need to have this 700 billion parameter model? Or is this 7 billion one maybe more appropriate and gives you the right results at a much lower cost point? Because cost is important here. Yeah? Some of these offerings, some of these models, especially the larger ones, are not cheap. And there are some other models that are much cheaper. Remember, was it a month or 2, 3 ago, when DeepSeek came out? Suddenly everybody's going like, oh, play. The Chinese, they figured it out. Yeah? And it's much lower cost. And it is open source. And then, until you start to experiment with it, until you do a little test and see, do these things really sort of compare to each other? Should I be using DeepSeek for this, or should I be using Claude? Or should I be using Llama? Yeah? And most importantly also, there's a number, so here are I just put a few decision criteria on here, but cost is an important decision criteria as well. If you build your system, if you are going to replace half of your customer service with an intelligent chatbot, but each of those queries to the chatbot costs more than your customer service agent would ever have costed, you're not having a healthy business anymore. I remember that Klarna, a company out of Norway that actually does so, for very expensive things that you want to pay, they actually give you the ability to pay it off in parts. Very successful business. they basically let go half of the customer service staff, replaced it by a smart chatbot. They're now rehiring all of their customer service agents. Why? Because it turned out that the quality of service that the chatbots were giving them, especially when emotional things are involved, like I can't pay this month and things like that, are something that chatbots would not have any emotion with. That they don't really be adjusting how people are actually really want to interact with digital systems. Now another thing in the decision criteria is that all these big models, they're all trained on Western data. They're all trained on English, Western European, or the US, or even things like 4chan and other areas where I wouldn't want to build my systems on. But so it is important to realize that they're very US-centric, and that if you ask them a question which would be more culturally appropriate, imagine you're in an Arab country and you ask sort of your chatbot, what should we be doing tonight? And if they advise you to go out and have a drink, then probably you've missed the opportunity to really be culturally aware that drinking in an Arab country is not a common thing to do. Yeah? And so important in all of that is that you have to realize that there are many more models out there. Quite a few you can find in Bedrock. This one is actually quite interesting. It's built by a small business in Kenya that is actually built on quite a few of the languages here in sub-Saharan Africa. Yeah? Or the Arab ones, or take for example customers in Japan and in South Korea. They've all built models that incorporate not only, because it's not just language, culture is embedded in your language. And that doesn't just go in, we can do translation really well. Translate from language 1 into English, then ask the question to LLM, get an English answer back and then translate it into your local language. You still have an English answer. It's just translated. Make sure that you understand also which models do I want to use if cultural sensitivity is crucial to you. So with all of that, it's important that you experiment. Try out. The best way to get rid of your anxiety and your fear of missing out is to start using some of them. And that's why we build Bedrock. Think about 1 or 2 small problems that you would like to solve with it. Go build it. And build it with different models. It's just a click of a button or just a line of code that you can change and use a different model. Look at what the results are. Make your own mind up. Remember that if you've been using one of these coding assistants, for example, that actually work quite well. But if you're subject to regulatory requirements and the AI made a change in your system and now you're somewhere no longer compliant for whatever reason, maybe managing personally identifiable information, if the regulator then comes to you and says you're no longer compliant, you can't say that's AI. AI did that. No, you're still on the hook for whatever you do with AI. AI makes predictions. We make decisions. You have to remember that we as engineers have the most amazing jobs in the world. Everybody else thinks, oh, he's an engineer, it must be boring. No, we can go to work every day and create something new. Which other job has that? Almost no other job has anything like that. But it comes also with responsibility. If we start using tools like AI coding assistants and things like that, we are still on the hook for the result of that. It doesn't take away your brain power and your common sense. So in all of this, experiment, use common sense, look at the outcomes of your experiments, and then make decisions. And really, measure, and remember I started off by talking about cost. Trade off the quality of your results against cost. Because that might be one of these decisions that you want to make. Now, before cloud, we all had this sort of, it was frustrating but exciting. The constraints sort of forced you to be creative even more than ever. So sometimes what you should just do is introduce again some of these constraints. yeah, to force us to be as creative as we can be. Because we can. And AI is just a tool to help us achieve what we want to do. But what we want to do is the creativity that sits in our own brains. Yeah? Don't discard your own common sense and everything that you've learned about software development. Don't throw that out of the window, because we suddenly have a tool that helps us to move from Java 12 to Java 17 without any interference. With that, now go build. Thank you.